Hi, I'm Chris Maidment, and thank you for joining me for another episode of TDK-Lambda Tech Tips. As some of you are aware, these are short videos giving you a technical insight into power supplies and their applications. Today, we're going to have a look at remote sense. You find this feature on many of today's power supplies. So, let's start from the beginning. This is a very simple example. I'm using our CUS400M power supply connected to a load, in this case a light bulb. However, this could be a laser, a ventilator, or any number of applications. Let's say the power supply is set to deliver 48 volts. You would naturally expect 48 volts to appear at the light bulb. If the power supply is mounted very close to the load, then you will measure 48 volts. However, what happens when the load is some distance away from the power supply? In this case, the power cables connecting the CUS400M to the load is much longer. Therefore, these wires will have a higher resistance than the previous example with shorter cables. Of course, we have current flow and now a higher cable resistance. Ohm's law tells us that there will be a resulting volt drop. In the example behind me, this is a drop of 0.4 volts. If the load is sensitive to such voltage variance, i.e. a reference voltage for scientific measurements or a simulated battery supply to test the system, this could unknowingly adversely affect the performance of the end application. Back to our example. If we connect the remote sense leads to the CUS400M options connector and also to the load, you can see that the power supply has now increased its output voltage by 0.4 volts to 48.4 volts. Which means we are now getting the 48 volts we wanted at the load. This is simply how load sense works. As you can see, the remote sense can automatically adjust the output of the power supply. However, there are limits, typically less than 1 volt. This is normally detailed in the datasheet. As you can see, the CUS400M can compensate up to 0.5 volts. Now that you know what load sense is, let's discuss some do's and don'ts. As if the sense leads are connected incorrectly, you could damage the power supply. To reduce the risk of noise on the sense lines, do use shielded and twisted pair cables. Do check that the output at the terminal has enough voltage margin to allow the remote sense to fully adjust. If we take our example, the voltage on the CUS400M should not be above 49.4 volts. If it is, then there is a risk that the overvoltage trip could be triggered by the operation of the remote sense. If the voltage drop across the output cables is greater than the power supply can compensate, then the load cable resistance needs to be decreased. This can be achieved by either reducing the length or increasing the diameter of the output cables. The sense cables have a polarity. They must not be connected reverse polarity, therefore do consider color coding. Do not sense across a fuse or a switch. If the output live is disconnected and the remote sense remains connected to the load, then unacceptable currents can flow, damaging the sense circuits. Well, that brings us to the end of this Tech Tips video. Thank you for listening, and if you have any questions on remote sense or anything to do with power supplies, then just message me. I'm here to help.